Hello everyone, I am going to explain basic concepts of complex number, and this topic belongs from chapter 5 from 11th class maths. So first point is introduction. We have seen that the equation x square plus 1 equal to 0 has no real solution. So this kind of equation we had in our 10th class. It's a quadratic equation, and this equation do not have any real solution. Why? Because if we want x square, then this plus 1 we have to shift in the right side, and when we shift this plus 1 in the right side, it's going to be minus 1. So it's going to be like this, x square equal to minus 1. And now if we want x only, then we have to take the square root. So when we take the square root, it's going to be x is equal to square root of minus 1. Now since square root of minus 1 negative number appeared, and which we cannot solve in the real number system. So now what is written, just see, and square of every real number is non-negative. So now because when we will find out from here x is going to be root minus 1, and we cannot find the value of x from the real number which can satisfy this answer. So we cannot solve it. So we cannot find any value of x from the real number which can satisfy this equation. Means if we have to search a value of x from the real number, whom when we will substitute here will give us the minus 1 is not possible in the real number. So first problem is this, that we cannot find the square root of the negative numbers in the real number system. And now the second problem which arises is in the quadratic equation. The second problem which we had faced in quadratic chapter in 10th class, and you already knew that the standard form of quadratic equation is ax square plus bx plus c. In this, the discriminant is b square minus 4ac. So it has three cases, either less than, equal to, or more than. So when discriminant is less than 0, that time simply we used to write down that it has no real roots. And why? What is the problem that it do not have the real solution? Because since it's less than 0, so discriminant is negative. As if discriminant is negative, then we cannot find its square root. That's the problem. So to remove the problem which we faced in part A and B, we have to move further. We have to extend our concepts from real number to some other system. So I wrote here. So we need to extend the real number system to larger system so that we can find the solution for the problem which we faced in part A and part B. So it is clear that the square root of negative numbers we cannot calculate in the real number system. Real number system is the number line which you had drawn from your childhood to the 10th class. That is named as real number. That is positive numbers, negative numbers and included 0. All the rational numbers, integers, all are the real numbers. In that we cannot find out any solution for the negative numbers. That's why this real number we have to extend up to the larger system. Now which system, that we have to find out. For that we move to the second point of this chapter, that is from real number to the complex number. So whatever problem we faced in part A and part B, which I explained in earlier, to remove that problem we have to find out a new system that is named as complex number system. Now what are the complex numbers, that we have to understand in this topic. So first is, since the negative real numbers has no real square root, which I already explained in the previous point, so we introduce a new number, that is, it is named as iota. The see here, read as iota. So such that iota's value is square root of minus 1. So student, in this it's a new thing for you. In complex number, this I has lot of importance, and it is read as iota, and iota's value is square root of minus 1, like pi. Pi's value you already know, that is 22 upon 7. In the same way, it's iota and its value is always square root of minus 1. To extend the real number system to another system called complex number system, which allows us to take the square root of negative numbers. So this iota will help us to move from real number to the complex number system, and this complex number system will allow us to find out the square root of negative numbers. So the different thing which we are going to introduce now is the iota. So now we move to the third point. So it's very clear that to find out the square root of negative numbers, we have to go to the complex number system. Before going to the complex number system, it's very clear to us, it should be very clear to us that what are the complex numbers. So that we have to understand here, that what are the complex numbers definition. So any number of the form x plus iota y, where x and y belongs to the real number and iota is equal to square root of -1 is called a complex number. So any number of this form, that is x plus iota y, this is named as complex number. And in this, what are x and y? X and y are belongs to the R. R means set of real numbers. Real numbers means +1, +2, +3 and 0, -1, -2, -3, all are the real numbers. So x and y belongs from the real number. It can acquire any value from the real number, and iota is square root of -1. So this combination of numbers is named as complex number. Now next, in complex number we have some points. First point A, the set of complex number is denoted by C. Like set of real number is denoted by capital R, in the same way set of complex number is denoted by capital C, and the complex number x plus iota y is usually denoted by Z. Means this number usually we used to denote by Z, and it can be in the form of any alphabet of English alphabets, either x or y or A and B. In our Ncert book of 11th class maths, the complex number is in the form of A plus iota B. So Z is equal to A plus iota B is the form of complex number in our Ncert book of 11th class maths. So we'll always take now this one. Now the C point is, in Z is equal to A plus iota B, A is called the real part. So there are two parts, students. First part is A, the second part is iota B. So A is the first part which do not have iota, that is A, is named as real part of Z, and it is denoted by RE bracket Z. So we should read it as real Z. So how to read it? Real Z, but short form is RE only. So the real part of Z equal to A plus iota B is A. In the same way, if real part is there, then imaginary part is also there. That is the point D. In Z is equal to A plus iota B, B is called the imaginary part of Z, and it is denoted by IM. IM is for imaginary. So imaginary part of Z. That is, this B is named as imaginary part because with B iota is multiplied. That's why this part is named as imaginary Z. Now for example, if we have a complex number, Z is equal to 5 plus 7 iota. So in this, if anyone tells us to find out the real Z is 5 and imaginary Z is 7. So like this we have to conclude. So I hope it's clear to you. Again I am repeating, the complex number is the combination of 5 plus 7 iota, and iota is what? Root -1, and among them which do not have iota is named as real part of Z, that is real Z is equal to 5, and imaginary part of Z is which have the iota, that is 7. Now we move to the fourth point of this chapter, that is condition for equality of two complex numbers. So in which situations we can say that the two complex numbers are equal? For that, two complex numbers Z1 is equal to A plus iota B and Z2 is equal to C plus iota D are equal if real part is equal with real part. So what is the real part here? In Z1 the real part is A and in Z2 the real part is C. So real part is same with the real part and imaginary part is same with the imaginary part, that is B is same with the D. So in that situation we can say that the two complex numbers are equal. Now suppose a question is given to us and it is available to us that 4 plus 5 iota is equal with a plus b, a plus iota b, then we have to find out what is the value of a and b. So obviously a is going to be equal with 4 and b is going to be equal with 5. So real part is equal with real part and imaginary part is equal with the imaginary part. So this is the condition of equality of two complex numbers. Now if we have to add the two complex numbers, so fifth point, addition of two complex numbers. So addition of two complex number, if z1 is equal to a plus iota b and z2 is equal to c plus iota d, we have to add. So when we have to add any numbers, we have to put the plus sign in between. Now here you can see this a and c are like terms because they both do not have iota, so bring together, and iota b and iota d, among them iota is common, so take iota common. So this is the formula for adding the two complex numbers. So add the real number with real number and imaginary number with the imaginary number, and iota just take common. Like if we have to add z1 and z2, so this is the process. First put plus sign, then open the bracket, and after opening the bracket 2 will add with 5, and here 3 iota and minus 6 iota just take common, and then 3 minus 6 is minus 3, so that's the answer. So z1 plus z2 is 7 minus 3 iota. So this is the process to add the two complex numbers. Now properties of addition in complex number set. So the properties, the first property is the closure property, closure law. Closure law means if we add two complex number, then again we are obtaining the closed number, means again we are obtaining the complex number or not. Closure number means whatever set is there, that is complex number set. If you are adding two complex number set, then it answer should again be the complex number. Then we can say that it is closed within the complex number. It is closed within the complex number. So from closed word, closure law came. So if z1 and z2 are two complex numbers, then z1 plus z2 is also a complex number. So here we already understood it. So if we add two complex number, again the answer is a complex number. In that situation we are getting again a complex number. That's why it is named as, so the addition is closed in the closure property. So closure law is applicable for the addition. Now we will move to the commutative law. Commutative law means if we interchange the places. So if you add z1 with z2 or if you add z2 with z1, in both situations you will get the same answer. So commutative law is hold in the complex number system. Now associative law. Associative law, in associative law, if we have three complex numbers, that is z1, z2 and z3, and if you have to add all three complex numbers, then firstly you can add z1 and z2, then whatever answer will come, in that you just add z3, or in second situation you can add any remaining two, that is z2 and z3, and whatever answer will come, in that you just add z1. In both the situation you will get the same answer. So this is named as the associative law. So associative law hold good in the complex number system. Now existence of additive identity. So additive identity means a number whom which when we add in the complex number, the identity not changes. So you already know additive identity in the real number, that is 0, because if you add 0 in 2 or 0 in 3, you are going to get the same number. So additive identity means a number whom which we add in any number, that number's identity will not change. You are going to get the same number. In the same way, so in complex number, z is equal to 0 plus iota b. So it's a complex number because iota is multiplied by 0. Conclusion is it's simply 0 only, because we know that 0 multiplied by any number is 0 and 0 plus 0 is again 0. But that 0 we converted in the form of complex number by creating it like this, and z is equal to 0 plus iota 0 called the additive identity. Here identity is not visible properly, but I wrote here identity. So it's a additive identity and it is named as zero complex number. So what is a zero complex number? z is equal to 0 plus iota 0 is named as 0 complex number, and it is additive identity in the complex number system. Now, existence of additive inverse. So, if we have a complex number z is equal to a plus iota b, then its additive inverse, simply just put the minus sign, that is, it's going to be minus z is equal to minus a minus iota b. It is same like the real number. If you have x, means if you have 2, then what is the additive inverse of 2? Minus 2. And if you have minus 3, then what is the additive inverse of minus 3? Plus 3. Means we are changing the sign only in the real number system. In the same way, in the complex number system also, if a complex number is available to us and we have to find out the additive inverse of that complex number, then simply just change the sign of real and imaginary, both the parts. So the definition is, to every complex number z is equal to a plus iota b, we have a complex number minus z is equal to minus a minus iota b, called the additive inverse of negatives of z. Now, so in this video I am going to explain only this much part, this much only, and in some more basic concepts are remain, that I will upload in my second video of chapter 5, and I hope these points are clear to you. Further, if you have any doubt, you can write in the comments so that I can clear out. And one more important thing, these notes I made from the 11th class Ncert books. So I suggest that don't write it. Already same thing you can get from the Ncert book. Simply you just understand the concepts, and then very soon we are going to start the exercise of chapter 5. So to solve the questions related to the complex number, these concepts are very important. So try to understand them properly. Thank you.